Finding roots or zeros of a polynomial. First, we need to remember that we can tell the number of roots by looking at the highest exponent in the polynomial. The number of roots can include real roots and or imaginary roots. So, setting the factors of a polynomial expression equal to 0 gives the solutions to the equation when the polynomial expression equals 0. The solutions of a polynomial are the roots of a polynomial. Since factors are a product, and the only way to find a product that equals 0 is if both or one of the factors are 0. The only way the polynomial can equal 0 is if one or more of the factors are 0. That might sound like a lot of words, so now we're going to see if we can find the roots or zeros of a polynomial by setting the polynomial equal to 0 and factoring, like in this example. So here we have x cubed minus 4x. We're going to factor that, pulling the x out, or factoring the x out, and then you'll notice inside the parentheses we have x squared minus 4. That's the difference of two squares, and that factors into x plus 2 and x minus 2. So we have the factors x, x plus 2, and x minus 2. We'll set each of those equal to 0. This will allow us to find the solutions or roots of the polynomial. So the roots are 0, -2, and 2. We find those by solving each factor for x. The first one already tells us x equals 0. The second one, we would subtract 2 from both sides and we would end up with x equals -2. The third one, we would add 2 to both sides and we would get the solution x equals 2, giving us these three roots. Another way that we can find the roots of a polynomial is by graphing them. We're going to use a program called GeoGebra, which is located on your computer, and it's going to be the quickest and most accurate method for our purposes. You'll go to GeoGebra under Education in your menu on your computer. At the top of the screen, you're going to choose View for a drop-down menu and click on Algebra View so that you have a left-hand column on your screen. So you should see a graph with a left-hand column. Then we're going to notice the bottom of the screen where you'll see the word Input. This is where you're going to be entering in your polynomials to be graphed. This is similar to what we did on the TI. Once we've typed in the polynomial, you'll hit Enter and your graph will appear. The real roots are where your graph crosses the x-axis. So let's look at some examples. For each of these examples, we want to find the number of roots, the number of real roots, and actually find those real roots, stating whether it's a double or a triple root, and then state the number of imaginary roots and obviously sketch the graph from the picture. So here, this picture shows you a screenshot of GeoGebra. So this is what you're going to see. Notice at the bottom where it says Input, I've typed in an equation. You'll use Shift-6 for your caret for your exponents. Once we've hit Enter, the graph will appear like this on this screenshot. Please notice in that left-hand column that you can see the function the way it would have been written on paper. Now I'd like you to click on the New Point button so that we can actually place points on our graph. This screen shows after I have typed or hit the new points on the graph where the graph crosses the x-axis. Notice again on that left-hand column, it shows you more information. It now shows you those 3 points where the graph crosses the x-axis. Remember, we've learned previously that these are the real roots. So our roots of this polynomial, we're going to have 3 of them, and all 3 will be real: -2, -2.79, and 1.79. We have no imaginary roots for this particular example. This picture shows another example. This is also a degree 3 polynomial, meaning we'll have 3 roots. Please notice here that this crosses what appears to be only at 2 places. But let's look at where it's touching at -2. anytime you have this parabolic shape that comes down and meets the x-axis, touches, and then immediately goes back up, or it can also come from the bottom, come up, hit the axis at one point, and come back down, you're going to have what's called a double root. So we do, in fact, in this example, have 3 real roots: -5, -2, and -2. That leaves us with 0 imaginary roots, just like in the first one. This next example is a degree 4, meaning that we could, in fact, have 4 real roots, but let's check to see if we do. We know we'll have 4 roots. Some might be imaginary. It appears at first glance that we only have 2 roots, or 2 real roots, excuse me, where it crosses the x-axis. At -4, that's definitely 1 root. But look what's happening at the 3. The graph rises from below, touches at 3, and then immediately rises again. If you have a graph like this, this is what's called a triple root. We have a triple root at 3. So the roots of this polynomial are -4, 3, 3, and 3. Again, we have no imaginary roots, and we have 4 real roots.